In this video, I'm going to show you how to export your data from a job. Any data and IP you generate through our platform belongs only to you, and we do not hold it hostage. Let's start by exporting a single image or the video of a time-lapse job. You can do this by clicking on this button over here, and then choose to download the current image or the video. The image will be saved as a JPEG, the video will be saved as an MP4 file. Next, we are going to get all the data from this job. Media and actual raw data. So click here on export and then toggle between media and data. Let's start with media first. So again, pretty straightforward. You can get the images and the video. If you want to do this on the tray level, just switch over to this. You also see this little preview here updating. So why am I getting two files? This job has been run with top and bottom light, so I will get two videos, one for top, one for bottom for the tray. If I switch over to plate, I will now get 28 because, as you can see here still in the background, this tray only had 14 instead of 15 positions filled. If I remove one of the lighting modes here, this will now switch to 14 obviously. You can access additional settings by clicking down here. This gives you a bit more control about what exactly and how things are getting exported when you're exporting your images and your videos. So the range is pretty self-explanatory. The default is set to all time points. In this case, that would mean 72. You can also choose to do samples. So not every frame, every time point, but maybe only every third. And you see this down here as the little preview updates accordingly. Size, you can change that to resized, meaning a lower resolution, smaller file, smaller image, smaller video. Can save some disk space, especially when you're exporting a lot of images. Folder grouping means that you can choose how exactly your download will look like. Do you want this on the plate level? So you will get 14 folders, one for each Petri plate in this case, and every folder will have 72 images, one for every time point. Or if you want to do it the other way around, giving you 72 folders with 14 images in each of them. Or no grouping at all, resulting in 1008 files. Let's now head over to the data tab here at the top to get all the raw data for this particular job, all the counts, the average time of appearance, the growth rate, etc. You can do this as an Excel file or as a CSV file on the well level or the object level. So what is the difference? The well here, by the way, is our Petri plate. So for this particular job here, if we would export that as it looks right now for the full range, we would get 14 times 72 rows. So for every time point, we have 72. We will get one row. We have 14 Petri plates, so that's where that comes from. You can change that by just selecting endpoint here. This will now result in 14 rows. Obviously, you will have to select the analysis that's available on this job that you want to export the results from. And then you can hit export and you will be sent an email with the file. All right, so this is how my export looks like on the well level. So you can see we have 72 time points. This 0 counts as 1, so this is why it's ending with 71. And here are my 14 plate IDs, my 14 positions. We get the link, the CFU count, maximum count, etc. All of these metrics here, and you can do some advanced post-processing or analysis with this. On the object level, you will have to keep in mind that if you have a lot of objects, for example, 100 CFUs on all 15 Petri plates and 100 time points, this will be a lot of rows, right? I mean, there won't be 100 CFUs right from the start, but in theory, you could have 100 CFUs times 15 Petri plates times 100 time points, or even more. So you can easily get into the thousands or tens or hundreds of thousands of rows. Just keep that in mind if you go for the full data range here on the object level. I'd recommend only using the endpoint for this. This is an example of an object level export that I downloaded as a CSV. Again, you get the device, date, time. So this is not hours, this is the time point. So depending on how you set your imaging interval, this can be something different than just an hour. Keep that in mind when you're exporting and plotting this maybe in Excel or another tool. For all the objects, as you can see here on plate A1 right here, you're getting the color values in RGB and HSV and the area. Coming back to an earlier video, this is where we are getting the data from when creating these filters, these categories for differentiating between microbes growing on the same plate that are visually different. So, for example, white CFUs and purple CFUs. We can use these values here to create filters and then basically getting two counts for the same plate.